let's go over example 4 of finding the domain of the quotient of these two functions. Now notice that in the function g is a quadratic equation, so I just go ahead and factor it out for the convenience of doing the work. Since both of these functions don't have any denominators, we know that both of the domains are all real numbers from negative infinity to positive infinity. So these are the work that I do ahead. Keep this video short. Now let's go ahead and find f of x over g of x. We'll just put everything together. We got x minus 1 divided by, instead of writing the original form, I'm just going to go ahead and write a factor form of this instead. 3x plus 1 and 2x minus 1. And of course, at this steps, we cannot we cannot simplify it any further because we don't have any common term to cancel out. And of course, each of these terms cannot be factored any further. Now at this steps, we have the rational expression with the denominator being the product of these two terms. So what we want to do is that in any rational equations, we want to take the denominator, or the factor denominator I should say, and we set it not equal to 0, and then we solve for x individually. Well, by the zero product property, we get to take this binomial term and set it not equal to 0 and do the same thing for this one. So we take 3x plus 1 not equal 0, comma 2x minus 1 not equal 0. And then solving for x, well, we can tell right away this is going to be 3x equal negative 1, divide both sides by 3. We got x cannot be equal to negative 1 over 3. So that's one restriction. The other restriction is divide both sides by 2. It's going to give us x also cannot be 1/2. So that's the second restriction for this steps. Now let's go ahead and find g of x divided by f of x. Well, that's going to be straightforward. We just take the factor form of g of x, and we divide it by the function f of x, which is just x minus 1. And of course, this steps here cannot be simplified any further. So same thing that we did up here. Take the denominator, set it not equal to 0. Oops. And then we solve for x. So at this steps, we know that x cannot be equal to positive 1. So we got the quotients f over g and the quotient g over f. Well, let's go ahead and put the domain of f over g and the domain of g over f on the number line. So let's start with f over g first. So let's see, we got negative 1 over 3, so maybe right here. And let's say put zeros right here, and we got 1/2, so maybe 1/2 is here on the number line. Well, let's sketch the domain of the function f first, which is all real numbers. And the domain of the function g is also going to be all real numbers. However, for f over g, we have these two restrictions. X cannot be equal to negative 1/3 and x cannot be equal to 1/2. So at 1/3, we put the open circle. And 1/2, we also put the open circle. So let's say this is the restriction, I'm going to call it A, and this is the restriction, I'm going to call it B. So this right here is A, this right here is B. Putting all of the restrictions from every step of this simplification process, from the function f, which we don't have any, and from the function g, which we also don't have any, we know the domain of the function f over g is going to be all real numbers except x cannot be equal to -1/3 and x cannot be equal to 1/2. For the interval notation, going from left to right, from -infinity up to -1/3, but not including 1/3. So we're talking about an open interval. Put a union sign to jump to the next part. From -1/3, not including 1/3, all the way up to 1/2, but not including 1/2. So it's another open interval. Put a union sign to go to the next part. From excluding 1/2 all the way to positive infinity. So that's another open interval. And this is the interval notation for the domain of f over g. Now what about the domain of g over f? Well, the domain of g over f can be done in a similar fashion. We'll sketch a number line. And let's see, for the function g, for g over f, we only have x cannot be equal to 1. So I'm just going to put 1 somewhere on the number line here. And of course, same thing, sketch the domain of the function f and g. And as mentioned just now, x cannot be equal to 1 is one restriction from this simplification process. It's all the restrictions from this simplification process. We don't have any restriction from the function f, domain of function f, and of course no restriction from a domain of function g. So really, if we were to graph this, we're going to have open circle at x cannot be equal to 1. And I put everything together, put all the x values in common and all of the restriction from both domains and from the simplification process. We have this as the domain of g over f. But what about the interval notation? So the interval notations are basically going from left to right, from -infinity up to, but not including 1. So that's -infinity, comma, 1. Put a union sign to go to the next part, from excluding 1 all the way to positive infinity. So that's an open interval. So this is the interval notation of the domain of g over f. It is read as all real numbers except for x cannot be equal to 1.